So the intention for 8b, looks like there's a lot here, but let's just break it down real quick. And there's a lot of words, like I said, with this topic. The really hard thing is just looking at all the new words that you'll come across. And you got to try and understand and remember what each one means. You can also, if you want to, you could use this, okay, as a place to put those words in if you don't know what they mean. Okay? But this is for your formulas, the second page. So you can put your formulas in there. Alright, so for 8b, what we're trying to aim for is understanding these two items here. This word called the common difference and what is an arithmetic sequence. Remember, sequence just means numbers, yeah? What is common difference and arithmetic sequence? Okay, so we're going to try and figure out what that is. And the next thing that we want to learn about is determining if a number or if a sequence of numbers is an arithmetic sequence. So if a bunch of numbers is arithmetic, that's what it's saying. Oh, that's what we're going to try and determine. And then we're going to be able to hopefully generate an arithmetic sequence using your calculators. So I hope you brought them today. And graph them as well. Okay, so all of this can be graphed. So a lot of the questions will involve graphing for this one. Alright, so now these are two rules, okay, that we're going to now be using and referring to whenever we are using arithmetic sequences. Okay, so I would suggest that at some point in time, you can probably put this rule in to use. Okay, so we're going to try and apply this rule to find D. D refers to the common difference. Okay. And also obviously use it to figure out whether a sequence is arithmetic or not. Okay, so this rule here, common difference D, is a rule that you use to find the common difference. We'll get into that a bit later, and then we're going to use a CAS to find the next few numbers in a sequence. Okay, so we're going to use a CAS a lot today. Not too much, but we'll be using it. And then also table of values. Okay, and this will be on YouTube, which Bobby stuffed up on his sack. Apparently. Table of values. Okay, we're going to include that here. Okay, so let's get straight into it. We'll go to this page here. So I think that's it's still the current page that we're on now. So an arithmetic sequence. Okay, that's the aim. Arithmetic keyword there, right? So when you look at these sequences here, we can see that they have some sort of pattern. So 2 to 7 to 12. What's the pattern, guys? What's happening? It's adding 5 each time. Okay. So that means, as a rule, to find the next sequence, okay, or the next term in the sequence, add 5 to the current term. That's the rule. So as a rule, you can basically say rule equals current term plus 5. Okay, that's what this is saying. Okay, current term plus 5. Okay, what about the next one? What's the rule here? Yeah, you can do that, x plus 5, but we'll be instead of using x, we'll be using another notation for it. Okay, so just keep that up, keep that in your mind. All right, so here, next term for this sequence, 200, 300, 400. What's happening? You're adding 100 each time, yeah? Yeah. So as a rule, according to this, so the next sequence, you have to add 100 to the current term. So the rule looks like this. Rule equals current term. Term plus 100. Okay, and you can probably notice what I'm going to do for the next few. So I can see this one is going 50, 45, 40. What's happening, Bobby?
Minus 5.
It's minusing by 5 each time. Okay, so that means as a rule, you'd write rule equals current term plus 100. Now, this isn't the proper way to write it, but I'm getting you to do this just as an exercise of what you used to writing an actual rule, because you'll be expected to write rules for this topic. And obviously, this one is just minus 1 each time. Okay, and as a rule, it's going to be current term minus 1. Okay, so sequences, okay, whenever you're adding or subtracting by a fixed amount, when it says fixed, that just means the same amount. So when you're adding by a constant amount or the same amount. So constant or same, that's what fixed means. So when you're adding or subtracting, okay, keyword here, adding or subtracting by a fixed amount to the previous term, this is what we call an arithmetic sequence. So basically, an arithmetic sequence, so a basic definition of it is adding or subtracting, okay, by the same number or by the same amount. That's what an arithmetic sequence is. So I want you to write this down, please. For an arithmetic sequence, it's basically saying adding or subtracting by the same number. That's what an arithmetic sequence is. So remember, sequence just means list of numbers. So a list of numbers where you're adding or subtracting by the same amount is called an arithmetic sequence. Okay, that's what that means. So when you add or subtract, arithmetic sequence. And there's obviously another name for when you multiply or divide. Okay, but for now, arithmetic sequence, add, subtract by the same number. That's what it is. All right, fixed just means the same or constant. Okay. All right, so that's fine, nice and easy. Okay, an arithmetic sequence, adding and subtracting by the same number. Now, there is a name that we give to that number that you're adding or subtracting by, and it's called your common difference. So the common difference, okay, is the amount that we either add or subtract by. Okay, that's what the common difference is. So this guy here refers to the amount that you're adding or subtracting by. Okay, and it's always the same number. Okay, and it's all common difference. You only find it in arithmetic sequences, yeah? So you'll only ever find it in an arithmetic sequence. You'll never find it in the geometric, just in arithmetic. Okay? And for common difference, we denote it using the letter D. So D means common difference. So whenever I ask you, what is your D? It's the common difference. What's the amount that you are adding or subtracting by? Okay, so D just means common difference. Now, as a rule, to find common difference, this is one of the first rules that I would like you guys to add on the second page of your booklet. How do you get your common difference, which is this? D equals any term minus its current term. All right, so to find the common difference, we use this rule. Okay. Second page of your notes. And where would you use it? You use it to find your common difference. So on the second page of your notes, I want you to write that rule. D equals any term minus its current term. Sometimes you'll see this, and I hope this doesn't confuse anybody, but you'll see it as D equals any term minus the previous.
There's a current.
I know, it's weird. I don't know why the textbook says the current term. I would prefer to use the previous term. Okay, and the reason being is, let's say you have a sequence that goes 20, 35, 40. If I want to find the common difference, well, I'm going to go this term minus the previous term. That's how I would think of it. I don't know why they use current term, so it's really weird. But just understand that this is saying you're just going to get one number and you multiply it with the number, you minus it with the number before it. That's how you get your common difference. So for example here, they've used this as a way to denote it. Any term minus the previous term. So if I use T3, okay, so it's T3 take away T2. If I use T4, well, it's T4 minus T3. If I use T5, what's it going to be, guys? Minus T4, okay, to get the common difference. Okay, so for example down here, actually let's label, okay, this sequence. So if I want to label this sequence, 30 is going to be called what? T1. Number 25 is called term 2, and number 20 is called T3. So if I want to find the common difference, and I'll make my own example here. So if I want to find my common difference for this, let's go, sorry. So for this sequence, I want to find my common difference. I'll go D, let's use another color. D equals, that doesn't want to change. Okay, I might go, so as a rule, you don't have to write any term minus previous. Okay, you don't have to do that one. You can just go straight into, I'll go like T3, take away T2, for example. Okay, so that means the common difference will be 20 take away 25. And the D, or the common difference, is -5 or -5. Because I can see also in my pattern, it's going down by 5 each time. So the next term should be -5, and it technically will be 15. Okay, so that means here this is how you use the common difference rule right there. Okay, so I can go D equals, and then any term minus the previous. Easy. Also, make sure to just label your terms as well in your sequences. It does help so you don't get confused. Okay, let's go to the next one, next page, or the next part, which is here. All right, okay, so what I want you to do is with these ones, before you start, I want you to label each term, find the common difference, and then tell me what's the fourth number or the fourth term. Okay, so find the common difference, tell me what's the fourth number. Show it using working out, please. So for this page, for here, if you want to find the common difference, remember it's any term minus previous term. So I've written down the rule there for you. So I can use any term here. I might go with, let's go with term 3, take away term 2. So it's going to be D equals T3, take away the T2. So it's going to be 8 minus 5. So the common difference, make some rule space here, is 3. Or positive 3. If that makes sense for you, or if that helps. So that means the common difference is positive 3. So that means to get the next number, you're adding by 3. So the common difference is 3, adding 3 to the 8. That means term 4 is, what is it, guys? 11. Easy. Alright, anyone want to do the next one for me? Give me what you got. Now tell me what you guys got for it.
T equals T2 minus T1, which is 23 minus 25.
Okay, so Joseph used T2 and T1, so he went D equals
T2
take away T1.
that equals to 23 minus 25.
Good, so 23 minus 25.
D equals -2.
-2. So the common difference is each time you're minusing 2.
And I did T3 plus D equals T4.
So you went T3 plus D.
Yeah, equals T4.
Because whatever this is, yep, so the same thing.
That's 21 plus -2, which is equal to 19.
So basically, this is a good way of showing your full working out. I like it. Really, really good. I hope it doesn't confuse people. But basically what Joseph's done is he's shown the full steps that he's taken. So he's saying that T4, term number 4, is equal to T3 plus whatever your common difference was, which was -2. So that means T4 is equal to 21 plus -2. But remember, plus and minus become a minus anyway. So plus -2. And he got 19, which is correct. So well done, Joseph. I really like that. If you want full marks, this is probably the safest step to take to get it. Okay, a lot of working out from what it looks, but we'll get there. It's not that hard. Look, I'm happy if you just went with, okay, show me your D. So if you went with this, and you just showed me this. You don't have to necessarily show this. Okay, but it's good. It's good. Okay, mark of a student who actually cares about his work. Okay, next part. So identifying an arithmetic sequence. So now we're going to try and recognize or identify whether something is arithmetic or not. Remember, what does arithmetic sequence mean, guys? What does arithmetic mean? Yep, so plus or minus by the same number. right? That's what that means. Plusing or minusing or adding or subtracting by the same number. All right, shh. If a sequence, is arithmetic, that means the common difference between each term will be constant. So that means basically you're going to be adding or subtracting by the same number. And we can use this idea to see whether or not if something is an arithmetic or something else. Okay, so if you look at these examples, which of these is arithmetic? So let's try and recognize here. What's the common difference? Well, we'll go T1, 2, 3, 4. Oops. Okay, so guys, can anyone tell me what's this going up or down by? 7. Yep. And how do we prove that?
T4 minus T3.
Good. So you can go T4 minus T3, which equals 42 minus 35, which equals 7. So that's correct. Okay. What about T3 minus T2? Will it give us the same number? Let's check. 35 minus 28, and that leaves 7 as well. So cool. T2 minus T1, that will equal 28, take away 21, which equals 7. So
we have to do all of that, though?
not necessarily, but it's a good way to check maybe 1 or 2 at least. No, maybe a good way to check 2, just to double check that it's correct. So that means because it's going up by 7 each time, this is an arithmetic sequence. So you should write that it is an arithmetic sequence. Yeah? Or yes, it's an arithmetic sequence. Okay, let's try the next one. Okay, so let's label this. This is T1, T2, T3, T4. Oops. So let's try doing T4 minus T3 for our common difference. Let's write that there. So let's go 54 minus 18, and that equals 36. Okay, fine. What about T3? Take away T2. What will that equal? Okay, so there already, we don't even need to check again, because I can see that the common difference here has gone from 36 to 12. So it's not constant, it's not the same amount, which means that this is not an arithmetic sequence.
Yes.
Okay, it's not an arithmetic. So to check if something is an arithmetic sequence or not, you're just going to find a common difference between a couple of terms. I would say 3 is safe. 2 is probably good too as well. A good way to check as well. But sometimes you might come to like the 5th number, between the 4th and 5th number. If you didn't check that, that might change. Okay, and yeah, then you've lost the mark already. So it's a good idea to just check a couple times between the terms to check if it is a common, the same common difference. So if they're the same, like all these 7s, then yes, it's arithmetic. But if they're different, then it's not an arithmetic sequence. Okay, I think you guys will be doing, some CAS work. So let's get our CASs out, guys.
Just plus.
Yep, so just on our CAS, we can actually generate arithmetic sequences on them. So once this loads, get your CAS calculators out, and we're going to open calculator. So just to recap real quick, arithmetic sequence just means it's going up and down, or a sequence where you're going up and down by the same amount, or you're adding, subtracting by the same amount. Common difference is that specific amount that you're adding or subtracting. And to find the common difference, okay, we use that rule of D equals any term minus previous term. Although the textbook says this, okay, I'm not happy with that. I would rather you use any term minus previous term. Okay, I think it makes more sense to use that. All right, so calculator. Just for finding the common difference, it uses any term minus its current term. I would prefer you use previous term. Yeah, just use any minus previous. It's easier. Yep. Okay, so on our CAS calculators, how do you generate a sequence?
Plus that, plus that.
Yep, but how do you start it? I think that's when people get confused. So I want you guys to add a calculator. So Control I, add calc.
How do you do that? Wait.
Just go Control I,
Wait, what the?
Control I, add calculator.
Why is it black now?
Just press count. Yes, yes, yes.
Alright, so to add a number, what you have to do first is write down what's your first term. So let's say, for example, my first term is 5. So press 5, then enter. And then when you found out your common difference, all you do now is you press the plus sign.
Let's enter.
And then you press, then maybe my common difference is 3. Okay, so if you keep pressing enter, it's going to keep adding 3 each time.
Oh, that is 5.
And you'll get your sequence. Okay, and it works the same with negatives. So if you go, for example, my first term is 7, and my common difference was -3, so I'm going to go -3, and then it'll give you your sequences. Just make a note that you understand what's your first number, and then term 1, and then what's T2, T3, T4, T5, because it doesn't say in the calculator. So you just got to make a note which term is which. We do these, okay? Alright, easy? Really easy. Okay. Alright, so that's pretty straightforward. Yep, we can do that. Now, the next part is graphing, and then I think that'll be it for 8B. Okay, shh, thank you. Last example, guys. So we're going to be graphing graphing a sequence, with an arithmetic sequence where the common difference is greater than 0, which means it's a positive number. Positive common difference, that's what that's saying. Okay, so in this sequence, 4, 7, 10, it is arithmetic. So it's told us it's already arithmetic, and it's told us the common difference is 3. Anyone want to tell me what's the first term? Let's write that down. Oh, let's recognize that. 4. So there's your term 1, yeah? Just make sure you make a note of what term 1 is all the time. Construct a table showing the number of term number and its value for the first 4 terms. Okay, so as a table, this is what you want to write. Okay, for the noobs who stuffed up their table of values, okay, this is one example of how you do it. So it's an X and Y table. You'll just have a long rectangle like this. So Bobby, make sure you're watching. Yeah, I am, because he stuffed up, he said.
It's because I saw the timeline on them.
Okay, so you want to have, make sure you have all the numbers that you can fit in there. For this one, it's a little bit tricky, but N is the term number. Tn refers to the term value. Okay, so N is the number, Tn is the value. You might be tempted to use Tn as the term number, okay, but N refers to the term number. Yeah, Tn is the value for it. So it wants us to make a table for the first 4 numbers. So that means for the first 4 numbers. What is the value for the first 4 numbers, basically? All right. I can already see T1 is 4, T2 is 7, and T3 is 10. Okay, so let's put that in. You got 4, you've got 7, you've got 10. Okay, and the common difference is +3 or +3. So that means that term number 4. So if we did Joseph's way of working out, term 4 would be T3. Shh, guys, quiet. T3 plus the common difference, which is T4 equals term 3 is there, 10. So 10 plus 3. Remember, common difference was 3. So that means term number 4 is equal to 13. Now, you don't necessarily have to show all of this, but it's a good idea to. Okay, it just really makes it easy for us to give you more marks. Okay, so I can see your thought process. So term 4 is 13. Okay. Alright, so the next part is we need to plot this in a graph. So this is an X and Y table, so it's going to be a scatter plot of some sort. Okay. So this
You have
is
to use our calc.
thinking back to data. No, you don't have to. You can if you want, but you can just do this by hand. So when you plot this as a graph, okay, you're going to have your table of values up there, but you're going to have your X and Y. Okay, so just copy me as you go. Make sure you label your axes. So this is 1, 2, 3, 4. This is my term number. And over here, I can see that Tn, so on my y-axis. Sorry that it's all red. It won't let me change color for some reason. So these ones, it looks like it's gone 4, 7, 10, 13. I might just go up by 5s, up to 15. So 5, 10, and then 15. Okay, so my TNs are there. Alright, so now we're going to graph this. Term 1 apparently is 4, so on n number 1 it's 4, so it should just be about here, under the 5. There's my first dot. Term number 2 is 7. Okay, so term number 2, 7, that should be about here. Now, can anyone tell me what direction is this going?
It's positive.
It's positive. Okay, good. And is it going to be linear?
Yeah.
Yes, it has to be linear.
It's pretty strong association as well.
It's actually a perfect association.
It is, yeah.
Yeah, because it's basically a straight line. So term number 3 is 10. So it should be about here. And then term number, or I should put this a bit lower. Sorry, guys. There you go. And then term number 4 is 13. So that's about maybe, yeah. So when you graph this, it should be a perfect straight line when you graph it. Yeah, draw the line. Draw the line. Always good to draw the line because it'll ask you to. Okay, and then in terms of describing the graph, you could use the three descriptors that we had. So is it what's the strength, what's the form, what's the direction if you want to. Okay, so the strength is, I would say it's strong, it's positive. Oops. Linear. Because there's no context here, I'll just say it's a strong, positive, linear graph. That works for me. I'm happy with that. So if we're describing it, it's strong, it's positive, it's linear. Because there's no actual, well, you could say there is a strong, positive, linear association between n and tn. That's more so with data. In recursion, we don't really do the descriptions like that. But you can if you want. I don't mind. I've never seen, I think in the SAC, I've never seen a question where it asks you to describe the graph. So, yeah, I don't know why. Maybe they will this year. But if you were to describe it, just talk about the association. All right, I want you to now do this as an example, guys. So, same thing, but now watch out for the common difference. It's -2. Okay, so same thing. Table of values, make the graph, describe the graph. Table of values, remember, X and Y table. Don't be a Bobby and skip it or miss it out. Okay, so remember, N refers to the term number. Make sure you use the correct notation. Tn is the term value. So you want to use the first 4 numbers. 9, 7, 5. I know that T4 will be equal to T3 plus whatever the difference is. So T4 is, T3 is 5 plus common difference of -2. So T4, that just basically means 5 minus 2, which is 3. So term number 4 is 3. And then as a graph, let's graph it, X and Y table, make it look nice and pretty. So this is the term number, 1, 2, 3, 4. Make sure you've got it all. And I can see that this, right, not very nice numbers again. I'll just go up by 2. So 2, 4, 6, 8, 10. And make sure you label the axis, please. I've already deducted marks for one person who I checked their SAC, for not putting a label on their axis. Okay, let's plot it. So number 1 is 9, so it's about here. Number 2 is 7, so that should be about here. 3 is 5, so that's here. Not really, as long as it's linear. Okay, if your graph isn't linear, then your intervals must be wrong. 4 is 3, so it's about here. So there's my graph. Yeah, 369 works too. That's good. So in terms of the description, guys, what do we say? What's the strong? Yep, strong, negative, linear graph. Sweet. Okay, don't need to do that. Okay, shh. Listening. Last bit here. Thank you, guys. Remember that if your common difference is greater than 0, which means it's positive. Shh, boys. When your common difference is positive, that means your graph will be going upwards. Okay? But if your common difference is below 0 or less than 0, it's going to be negative. So it's going to be going downwards. Okay? Alright, so that's it for this. In terms of our success criteria, I just want to make sure that we now understand. Do we know how to use the common difference rule? Yes? Okay, good. Do we know how to make a sequence in our CAS? Yes? And do we know how to make a table of values now? Good. So make sure you do that on your SAT.